So here's the next question, number 19. And the question reads, in a 100 bus power system, there are 10 generators. Let me just underline that so that we know what we're dealing with. We have 100 bus power system and we have 10 generators. In a particular Newton-Raphson load flow technique in polar coordinates, 2 of the PV buses are converted to PQ types. So we have 2 PV buses that are converted to PQ. In this iteration, the choices are the number of unknown voltage angles increases by 2 and the number of unknown voltage magnitudes increases by 2. So you will notice that in each option we are dealing with 2 things: voltage angles and voltage magnitudes. These are the 2 with different combinations, and we'll have to find out exactly which one is right. So option A says that the number of unknown voltage angles increases while the voltage magnitudes increases by 2 as well. Option B says voltage angles remain unchanged whereas the unknown voltage magnitudes increase. In C, it says that the voltage angles increases and voltage magnitudes decrease by 2. And the final one says that the voltage angles remains unchanged and the number of unknown voltage magnitudes decreases by 2. All in all, we have 2 aspects: voltage angles and voltage magnitudes. So let's see. So the total number of buses are 100 given to us, and there are 10 generators. So that immediately tells us that the number of load buses would be 100 minus 10, which is 90. So I'll note that down right here. So we have total number of buses 100, number of generators 10, which means number of load buses is 100 minus 10, 90. So there are altogether 90 load buses. Now you should know that at every load bus, the voltage magnitude and the voltage angles must be calculated. Both must be calculated. Both aspects that are given in all of these 4 choices. So at every generator bus, so this is at every load bus, okay? At every load bus, we need to calculate the magnitude, the voltage magnitude, as well as the voltage angle. And for every generator bus, we need to calculate Q and delta must be calculated as well. Now, at all the buses, delta will be calculated. So it shows that for load, though there is a change, but the angles need to be calculated nonetheless. So this means that no matter what kind of bus it is, we need to calculate the angle, the voltage angle. So this means that there is no change in the voltage phase angle calculation. There's no change. Okay. So the unknown voltage angles does not increase. It remains unchanged. So this is our Q here. Okay. So the voltage angles remains unchanged because we need to calculate no matter what kind of bus it is. Then next it comes down to the voltage magnitude, whether it increases or decreases. Now the question says that it is Newton-Raphson load flow technique. Now during the iteration, 2 generator buses are converted to PQ type. So that means that 2 generator buses change to load buses. So 90 becomes 92. So we are adding here, it becomes load buses. Both those 2 PV buses are changed to load buses. So 90 becomes 92. So that means that the voltage magnitudes increase by 2. So the right option here is increases by 2, here B. The number of unknown voltage angles remains unchanged and the number of unknown voltage magnitudes increases by 2. I hope this has helped.